Okay, so question 11. So the ramp's inclined at 30 degrees to the horizontal. The trolley has a mass of 20 kilos and it's being pushed up the ramp by a forcer with a net force parallel to the plane. So first thing we're going to do is scroll down to see the rest of the question. So sketch and appropriately label all of the forces acting on the trolley in this situation in the diagram below. So there are three main forces whenever we start to do our force diagram. Now you always have your weight force, which is just the weight of the cart acting with the force of gravity that goes straight down. Then we have our other force that is called our normal force, and it is acting perpendicular to the plane. Then we have our force that's parallel, that's stopping the cart from rolling down. So that's just our force there. So they are the three forces that we need on this plane. Now, the reason why we decide to change this weight force that goes down like that, we're going to resolve it into its two components. The reason why we do this one and not these two to make it parallel to the other two forces is because then I'd have to resolve two forces opposed to just resolving one. So that's our sneaky trick around it. So when I want to resolve the weight force, if this angle here is 30 degrees, this angle up here is also going to be 30 degrees. If you're not sure how that works, draw it out, do some experimenting with it, but, you know, is what it is. So that's 30 degrees. So now we can apply what we know about trig. So sine theta equals opposite over hypotenuse. So if this is our angle, this is the opposite side, and this one here is the hypotenuse. That means that the opposite side, or our, we'll just go with opposite at the moment, that is equal to 20 g sine of 30 degrees. So that force going the opposite direction, 20g sine of 30 is equal to a half. So I can do 20 times a half equals 10g. And g is equal to 9.8. So 10 times 9.8 makes 98 newtons of force going in that direction. So if I want to resolve the other force too, I can do that by doing cos theta is equal to the adjacent over the hypotenuse, which is going to be equal to, the adjacent is, what's that, 20g root 3 on 2. And I can simplify them by doing 10g root 3. Now, the question hasn't asked me for this yet, but it is a good habit to get into to resolve those forces straight away so you know exactly what you're looking at. Okay, so we want to determine the minimum force required by the worker to prevent the trolley from rolling down the ramp. So if we want them to not let it roll, that means we want the acceleration to be equal to 0. Then we have to group together all the forces acting in that direction. So this one here and this one here, which is the weight force that's acting that way. So that one there. Okay, so 0 is equal to the force. We're going to take, this is our positive direction, minus 98 newtons, which means that the force is equal to 98 newtons. I'm guessing the working that they probably wanted to see in this section is what I did over here. Okay, the next one. If the worker exerts a force of 178 newtons on the trolley, determine the acceleration of the trolley up the ramp. So, force is equal to mass by acceleration. So then our forces... I'm not editing this. Go away. Don't spray me with the hand sanitizer. Sorry about that. So the forces that we've got that are going to be acting on this are the 178 acting in the opposite direction minus the 98 that the cart is using to not roll down. So that's going to be equal to our mass of 20. And our acceleration is just a still. So that's the one we're going to solve for. So when you subtract these two from each other, that's going to make it 80. Then I can bring across the 20 by dividing. So then A, acceleration is equal to 4 meters per second squared. Okay, so last one. A worker pulls the trolley up the same ramp with the net force parallel to the plane. I'm going to not read this. All right, so just look here. There's velocity. We're going to use velocity. We're going to use time as 2 seconds. Oh, don't even think about it. Okay, sorry. Just having some technical difficulties. So we're going to determine the position of the trolley at the bottom of the ramp after 4 seconds. All right, so let's think about what we have and what we need. So currently we've got velocity is equal to t over 2. We want to find out its position. So position is the xt is equal to. Now we're going to have to integrate our velocity to get that one. So when I integrate that function, I'm going to end up with t squared over 4, because normally the 2 would come down, multiply the denominator, and that's what I'll have. Now, because we've integrated, we've added c to this. So that's why they've given us this extra piece of information here. That's going to allow us to solve for c, and then we'll have a complete equation so that we can work out what it is at 4 seconds. So we're going to let t equal 2, and x at time 2 is going to be equal to 5. So 5 equals 2 squared over 4 plus c. So that's going to be 1 plus c. So I can take this to the other side and I end up with c equals 4. So my equation for this thing really looks like this. Okay, so last part. Now all I need to do is put 4 back into the equation to work out what the displacement is. So our displacement at 4 seconds is equal to 4 squared over 4 plus 4. 4 squared is 16, divided by 4 is 4, plus 4 is 8 meters. So after 4 seconds, this thing is 8 meters away.